Everybody, let's go and configure the BGP protocol between the PA firewall 1 with your edge router and advertise certain BGP routes. So on the inside we are running OSPF, and between the PA FW1 to the edge router, let's go and configure eBGP as the protocol of choice. So on the edge router, what we'll do is we'll go ahead and configure, let's say we remove that static routes whatever we have configured, so no IP route. Okay, just for example, if I see do show IP route completely, so I have got here the connected route only. Yeah. All right, so to configure BGP, my first command is router BGP. My local ASA I give it as 1000. My neighbor in BGP, you define the neighborship manually, so it's neighbor over the connected segment, and it is 123.112.0.1. so a PA FW1 outside interface is acting as the BGP neighbor, or specifically eBGP neighbor, which is having remote AS of 100. So my AS is 1000 on the edge router, and the PA firewall is running on BGP AS of 100, so it is an eBGP neighbor. And let's say I'm advertising this network 99 with a mask of 24 into the BGP process. Okay, so if you see do show IP BGP, my local network 99 is advertised into the BGP process. So on your Palo Alto firewall, you can click on network, under network click on virtual router, go to the virtual router that you've configured. So I'm using the default VR for now, and you can click on BGP. First of all, enable the BGP protocol over here. You can define the BGP router ID, you can define the local AS number, so in my case it is AS 100. Yeah, and in general configuration, you can select reject default route if the BGP protocol, if you don't want to install in default route. Okay, install route when you want to receive the route advertisements, so click on install route over here. You can define the AS format, whether it's 2 byte or 4 byte. I leave it as 2 byte. This is the default local preference value. Path selection process, if you want to add in authentication profiles with your neighbor, you can add it over here. In the advanced section, you can change the graceful restart timer. You can add the route dampening profiles if you want. Okay, in the peer group section is where you can define the neighbor or the peer address. So I click on add, I name this is my eBGP peer with the edge router. Okay, type is eBGP or iBGP, so I define it as eBGP, and yeah, so I can define the peer information. Click on add, so name this is eBGP towards the edge router. Okay, okay, peer AS is on 1000, and my local interface address is Ethernet 1/2. My local IP is on 123.1.1, and the peer address is 123.1.1.1. Alright, I can also specify FQDN if it is supported. Connection options, where you can change the the different BGP timers if you want. And advanced section, you can make the route reflector configuration. All right, yeah, if you want to add any BFD, you can do that. Let's click on OK. Click on OK here. You can add any import or export for doing redistributions, conditional advertisements, BGP summarization, right? If you want any sort of redistribution rules, you can do that over here. As of now, you can just click on OK and commit your changes. So ensure that if you look for the preview changes, I click on the preview changes, so you can see what configurations would be applied. So you can see the BGP is set to enable as yes. You can see the neighborship and the respective BGP configuration that is allowed here. Okay, good. So let's close that, click on commit, let the commit process begins and let it get completed. So let's write down some BGP key points over here. So BGP key points that you must be knowing as engineer when you work with. So first of all, what is BGP? So BGP is, so first thing that you might face with this question called as what is BGP in the interview, or might be when you take an interview to any of the interviewee, you can do that, you can ask this question. So first, you might ask for what is the purpose of running BGP. So I can say that BGP is a protocol which is used to exchange exchange any routing information between different autonomous system, or you can say different AS. It is considered the backbone protocol of the internet, right? It is considered as the backbone protocol of the internet. Okay, you can ask for the type. So basically it's a path vector protocol which is designed for inter-domain routing, which is between different organization or different ISP, right? Which could be different organization or different ISPs. Okay, regarding what is a transport protocol BGP uses, so BGP runs over TCP, port number is 179, to ensure reliable delivery of routing information. Okay, BGP roles and different types could be the second question. So what are the different BGP roles and different BGP types you have? So first type is your eBGP, which is also called as external border gateway protocol. So the idea of eBGP is to operate between routers in different autonomous system. So operate between routers in different autonomous system. Typically it requires direct connectivity, so make sure that the routers are directly connected to each other. Typically requires direct connectivity, or basically the TTL value to reach the neighbor IP, TTL value to reach the neighbor IP address is 1. Okay, and if it is not, then unless you need to configure eBGP multi-hop. So this eBGP multi-hop feature should be configured if the neighbor IP is reachable, which is more than TTL value of 1. Okay, next type is your iBGP. So iBGP is basically your internal BGP. So in case of internal BGP, it operates between routers within the same autonomous system. So operates between the routers in the same autonomous system. Next point could be, it does not require direct connectivity. So does not require direct connectivity. So however, I can say however it needs full mesh design, full mesh design or route reflector based design to work with. The neighbor IP address should be reachable within TTL value of 255. That means the neighbor IP, whenever you can configure on the IBGP neighbor statements, make sure that the neighbor IP is reachable within TTL value of 255. Okay. Most of the time, you have this configuration, you have requirement of manual neighborship. All right, so you've got BGP neighbor establishment. So BGP, we normally say BGP peers are configured manually. Most of the times you will have that. Okay, so one of the example, let's say on Cisco routers, you can say, for example, router BGP, let's say it's 65001. You can define the neighbor, then define the neighbor IP address, then define the remote AS, right, then define the AS number, then you can likewise you can define the other neighbor as well. Let's say YYYY as a neighbor IP address. Likewise define the remote AS number of that neighbor, and make sure that the remote AS number should be different than the local AS number. So here my local AS number is 65001. The remote AS number, whatever I specify here, should be different, right? For eBGP and for IBGP, the remote AS number should be same as my local AS number. Okay. There is a feature called as BGP state machine. So when the BGP routers are in neighborship process, then in the neighborship process we explain that by working with different BGP neighborship state machine. So the idea is BGP will progress through several states, which is important to remember. So states are idle, connect, active, open, sent, open, confirm, and establish. Okay, until a session is successfully formed. So these are the different states that the BGP neighborship will progress through, and each state has got its individual meaning. Okay, so always remember that if the BGP neighborship are fully or successfully established, two BGP routers, they are in complete neighborship, so they should be showing in the established state, or else anything when it is like termed as as an invalid neighborship or neighborship is not forming, so you will see that the BGP neighborships are in this particular states, okay, without any established keyword. All right, so there are different attributes that the BGP uses, right? So each attribute has got its own way of working, right? So I'll just name some few attributes, or you can say the common attributes of BGP, as it is a path vector routing protocol. So attributes like AS path, okay, is used. Attributes like next hop IP is used, then local preference, then your multi-exit discriminator, then community, right? Attributes like weight is a Cisco proprietary attribute, etc. Okay. All right, so on a summary note, you can say BGP is very critical for inter-domain routing, enabling global connectivity by exchanging routing information between the different networks. In BGP you use robust policy control you can have different BGP engineering with respect to scalability mechanisms, and you can have a detailed path selection process by working with different BGP attributes based traffic engineering to define BGP to select a best path than the other. And it makes BGP a very powerful protocol for network operators, despite its complexity as compared to IGPs. All right, so I hope these key points will work out as of now. And if you are in requirement of knowing BGP completely, then we have got a separate course of BGP as well, so which is BGP bootcamp from beginner to expert. You can look into that and get acquainted with exact BGP knowledge that you need, right? So yep, I hope it is clear. Thank you for joining. Let's go ahead and verify the BGP neighborship, which we have yet to verify. The commit is done, so let's go ahead and verify the BGP neighborship once. So on my edge router, you can see that the BGP neighborship with my Palo Alto firewall is up. Okay, so you can see do show IP BGP summary. So you can see that the neighborship is up. It's running BGP version 4. State is blank, which means it is established. Likewise, on the Palo Alto firewall, on the default virtual router, click on more runtime stats. You can select the BGP tab, and you can see the peer sub tab, and you can see that, hey, you've got a eBGP peer. Status is established over here. Okay, good. So I hope it is clear. Thank you for joining, and I'll see you in the next lecture, guys.